Hi guys and welcome to the channel. One more video about OpenAPI, but we'll talk about the design first approach or the contract first approach. In the previous video we tried the code first generation of OpenAPI schemas, but since that I've done a bit of a research on the topic and found some really nice tools that can help building a nice pipelines around OpenAPI specs, and we're going to discuss that today. So first of all, I highly recommend go to this page and read the official best practices from OpenAPI, and there are a lot of interesting things here, but the main one is that the recommended approach is actually design first, and what that means is that developers are writing the specs, OpenAPI schemas, before doing the implementation. So the contract that we defined in a schema will define the implementation in the service itself. And after that, our schemas now are kind of like a first class citizens, and they will be under source control, and probably there will be in a centralized repo where everyone in the company will have access, and they can read the API, suggest changes with pull requests, and basically work on the contract level without looking into implementation details. Let's think about what we want to do in the pipeline to protect us from some unwanted changes. So let's say we will have like a repo for OpenAPI specs, and let's say that the main or like the master branch will be the source of truth. But on PRs, we want to run some checks, right? And the first is, I believe, pretty obvious, but I really like to keep files in consistent state, in consistent formatting. So we will apply formatting for the specs, and they could be a JSON or YAML. I'll focus on YAML today, but for JSON, probably something like JQ could be an option. For the YAML, I found YAML FMT tool. Should be good enough for our use case. So once we check the formatting of the files, it's fine. Then I think we need to run linting as well. And I found a tool called Spectral, I believe, and we'll take a look into features in a sec. So this linting will check common problems that are specific to OpenAPI specs. It could check like some missing fields, like descriptions, and keep our specs in consistent format, and also this tool is really powerful because it allows you to define your additional rules for the checks, and they're actually nice examples of the real world rule sets from big companies. So take a look into that in a sec. And after that, what else we want? Yeah, so if our API is stable, we really want to protect it from breaking changes. So if you introduce a breaking change, you probably want to introduce versioning, and or some kind of like, if you control all your clients and all your client services, you can just resolve the breaking changes with communication, right? So it just depends which order you introduce the changes. But really, for the PRs, before I just think you need to protect from accidental breaking changes on the PRs. So for that, we'll use Oasdiff, an extra tool that will help us with breaking changes and the change log. And that's related to the pipeline. If all of these checks are passing, it's fine to merge the changes, and after that we need to implement the change in the service. But an interesting thing is how we will force our service to follow their contract, right? And this will be the final step of the video, how to enforce OpenAPI checks in the request response of the service, right? So I created a simple payment service API, and it really just have two endpoints now. One is post for incoming payments to create a payment, and the other one is get, and it will expect an incoming payment ID as the pass param. Some validation here, so we say that it is required and the schema is string and specific format is UID. So we expect UID to be the payment ID. And then you want to define schemas for the responses. Like for example, for 200, we'll return JSON object with some fields. For 404, we'll just return it's not really defined here. We just have like the description of the response. But it's a good starting point anyway. So imagine we have a schema like that, and let's run the YAML format command first. So it will be resources and then payment service YAML. So it works. And for example, let's say I added a bit of extra spaces here. So if I run it once again, it is removed and we have a nicely formatted file. So I believe that's trivial so far. Next, let's take a look into this .spectral YAML. And you can basically generate that by running a command like this. So what that means is we will use predefined rules recommended by Spectral for OpenAPI spec, but it's just like a starting point. We can add extra rules after that as we want, and we'll see some examples later in the video. But let's try to run open Spectral lint and then our YAML for the schema. And as you can see, it's not great so far, and we have a couple problems. So let's try fixing them. So it says that we need contact block here, and let's just put name, my name. Let's rerun it. So yeah, I believe one less problem. And then we have this common problem that we defined our response statuses as a number, and it expects it to be a string. Let's fix this, and I believe we have one more. Yeah, this one. Let's run it again. So better. We now just have two warnings. And for that, I think we can go and change our rule set if we just don't want those tags. So if you go to the GitHub, and there's real world rule sets, and there's a collection of companies using this tool, and they providing examples of their rule sets. So we can extend it like this, and probably if we do this operation tags false, it will just ignore the problem that we have. So yeah, let's give it a try. So we need to go to our configuration file, put it here, and try it again. Yeah, and now no results with error found. So it basically means that our linting tool is happy now, which is good. And the last one is, as I said, the OpenAPI diff tool. So the goal of this command is to check for breaking changes in the OpenAPI, and it will compare, for example, the previous version of the schema with existing one, or if we're using the GitHub action, and like GitHub action is provided, it can check the master branch or like the main branch version of the schema and compare it to the version from our pull request. So this is really, really nice. And if they are bringing changes, there'll be error warnings, error logs in the output, and we can block our PR. And if it's successful, we can actually generate a change log and probably publish it as release notes or commit it somewhere. So yeah, this is how the tool works. And that's the end of the pipeline as we described it, right? Let me double check. So yeah, we applied formatting, we checked how linting works, and then we checked this OpenAPI diff tool. And the final question is, once we implemented our service, or for example, we covering our existing service with spec, how we easily can force or check that our API is implementing the correct spec. And this is a bit of Clojure code here, but it is a Java library, so you can use it in Java, any Java application. So it's from Atlassian, and it's called Swagger Request Validator Core, and it supports OpenAPI version 3. And also there's a set of libraries. So for example, if you're using Spring, you probably want something like that. But in Clojure, it's enough to use the core. And also the other interesting one is the validator for the wiremock. So basically it means when we do tests that consume our API, in tests, if we use wiremock, we can add an extra validator. And once we write our stubs, we can be sure that they are valid against the real OpenAPI spec. And this is really valuable because it just removes this headache for developers to make sure that you actually testing against the thing that you will see in production or development. So this is good. For Clojure use case, this will be done as a middleware for the Ring application. And I actually found this small library, but really you don't have to use it because the only thing it's doing is just a thin wrapper on top of the Atlassian library that I've shown. And it provides functions like validate interaction. So we'll check the request response or just validate request or validate response. But really, yeah, it's not much code, so you can just recreate it yourself. And the heavy lifting is done by this Java library. So for the implementation, I haven't done any routing. So I just have a single handler, and inside I'm just getting the request, and I can put it inside, pass it inside the validate request function here, and the validator is defined from the YAML that we've just seen, and it will be request validation, and after that, when we do the response, there'll be a validate interaction, and it will validate both request and response. So there'll be no errors thrown now, but you can see you can do whatever you want. For example, if this function validate request returns some errors, you can just throw a like exception or return like 400 error message with details. And it's really valuable to validate the response as well. So in real application, once the request is finished, probably it doesn't make sense to throw an exception if it's not valid response, because everything already happened. But at least warning is a useful thing. And it's also really useful in tests, because when you test your implementation, you can just enable strict checks for the responses as well. And you'll see when your code returns something that's not valid against the JSON schema that we have. So yeah, let's give it a try. So what I need to do is to actually have it running here, but I can restart really quickly. So I just run lane run, and it will start the server for me. And then I have an example request. As you can see, it uses ABC as payments ID, but we've seen in the schema that it expects UID. So it should throw an exception. And as we can see here, we have some logs about responses and requests. So this is for request, and it says that our string that we provide is not a valid UID, which is good, what we expect. And also, I just returned some random stuff from the response, and it is also not happy that we have some additional properties that are not supposed to be in our response. And the final thing is about the client. We briefly covered a library called Martian last time, but it's just one more example. So if you have an OpenAPI spec regarding clients, you have multiple options. So you can use OpenAPI generator tool that we used in previous video to generate clients code in multiple languages. So the result that you get when you run it for Clojure clients is a bit ugly, I would say. I didn't really enjoy that, but I haven't worked too much, so I cannot say for sure. But instead of code generation in Clojure, we can do a different approach, which is more like API discovery, I would describe it. So the library will have our OpenAPI schema as input, and it will generate, read the spec and generate the routes and some client functions that we can call, and it's easier to show what it's doing. So let's say we have we got our OpenAPI spec, as you can see right here from the file, and then if I run explore on that, it will show me routes that I have. So create incoming payment with the description, and also get incoming payment by ID. And then let's first of all call it with something invalid. So let's say I want to remove this and I want just integer. Let's run that. Yeah, as you can see, it says that incoming payment ID is not matching our schema, and it's done on the client side. So we'll have this extra validation for the clients. And also these names are predefined. So if you put something invalid here, it will say like a known operation or something like that. So yeah, you don't have to write or remember how to build your API path, etc., which is nice. But if we just do a normal call with a UID inside, it will get the result, and also it automatically decodes the body because it knows that the content type is JSON, and you can use this directly. So this is pretty cool, and also you can enable, I believe, validation for the response bodies, etc., because the library knows the specs and JSON schemas. So that's all for today. I hope that was useful. I'm still exploring options regarding OpenAPI. and probably I'll learn more over the time, and I'll definitely share what I've discovered. And yeah, thanks a lot for watching. See you next video. Bye bye.